Hi, I'm Stas. Actually, I didn't plan to make this tutorial. I was working on a completely different one, which is coming soon. Uh, when this little pop experiment turned into surprisingly interesting way to visualize the audio. So I decided to share it with this 5-minute tutorial. And let me know in the comments if you like this shorter format or not. And now let's get started. Start with the audio input. In this example, I'm using audio file in-chop in a mono mode, followed by audio spectrum chop. You can use audio device in-chop instead. The setup is exactly the same. Next, add a resample chop. Turn off time slice and set method to same rate new interval. And change the units to absolute samples. I'll use a range from 0 to 199, so we get 200 frequency samples. Add a null after that and call it a audio thing. Now we have a compact, stable spectrum signal that we can map into our pop points. Create a line pop, set up as a horizontal line running from -1 to 1 on x-axis. Make sure it has normals and point those normals upward along y-axis. These normals will become our particle's initial velocity, so their direction matters. After the line pop, add line matrix pop. In its line strip settings, use distance from start normalized as a lookup index attribute. This gives every point a normalized value from 0 to 1, independent of the total number of points. Set the channel scope to audio fin, then map the spectrum into a new point attribute called birth. At this stage, you could also map the audio values into position y and get a conventional spectrum line, but instead we will use the spectrum to decide how many particles each point will emit in a frame. The raw spectrum values are usually too small, so multiply them with a math chop. Start with something around 50, maybe 100, and tune dependent on your audio source and how density spectrum you want. Now create a particles pop. In the map setting, set the initial velocity to use the incoming normal attribute in multiply mode and change the multiplier in the main tab. This makes the particle move in the direction of the normals from the emitter geometry. Before switching to the birth attribute, save the project. Sometimes TouchDesigner occasionally freeze, at least on my PC, so it's better to save. Then, in the emission setting, switch the emission mode to use birth attribute and set the attribute name to birth. Start the simulation. Now, every frequency bin emits the number of particles, based on its current amplitude. Loud frequencies produce dense streams, quiet frequencies emit fewer particles. At first, particle streams will probably go straight upward. This is because particles are born in the same point and inherit the same normal direction. To break up those clean vertical lines, increase jitter birth until you get the effect you want. The right value depends on the distance between points in your emitter line. Adjust the particle lifetime and lifetime variation to fit your rendering setup. A useful target is to give particles enough time to travel across the visible frame before it die. Set the max particles value fairly high. Once the simulation reaches that limit, new particles cannot be emitted until existing ones die. So, that's the core idea. The project file is available for my Patreon supporters, if you want to use it as a starting point for your own ideas. And now it's time to experiments. Replace the line with a circle, or a pattern pop, or a trace pop, or maybe text in a line strip mode. Add noise to emitter position, or add noise to the normals, so particles fly in a more chaotic direction. Or maybe add noise not to the emitter but to the particles instead. Blend between different shapes. Try a different rendering style, make it soft and smoky, or make it sharp, add trails, or add bloom. Or color it in a classical yellow and purple spectrogram palette. Just keep in mind, with every extra transformation, it becomes less of an audio spectrogram and more of an abstract audio-driven visuals. So experiment with it and share your results. Have fun! Bye!